Okay, so this is a post-build video of my short straw rocket. It got that name for obvious reasons, but it's came about, its destiny came about because somebody sent me some nice carbon fiber fins, and I had a short tube laying around, and I had a 3D printed jig for doing fin alignment, and I tacked them on one night and said, wow, that's a pretty cute rocket. And then the next morning I looked at it and said, wow, that's a pretty short rocket. What are we going to fly in there? And I guess I could have stuck in a 38 millimeter and 29 millimeter motor in there, but I didn't really want to do that. Of course, you want to fly it with the biggest thing you can, so I wanted it to be 54 millimeter, and I really like the K550, and so I pulled out that case and I said, well, that's a pretty short rocket. And so if I slide it in here, we can see but there's really almost no room for a coupler in there or anything else. So we were left with a very short rocket. It played around for a couple of years, still trying to figure out what to do with it. It did along the way have these things that I've used for motor retention before. They go on easily enough. They clip there. Everything goes through the tube. And so it slides in like that. And still too short, but it gave me some ideas. This works well for motor retention, but that's about it, and it's too short. So I'm like, well, maybe I can make a coupler out of it, but I really didn't want much more on there other than a nose cone since the rocket was already so short. So yeah, it took a while to think about, come up with a solution. I ended up coming up with uh, sort of a modified design based off of that. This is printed in ABS plastic. It has a similar ability to clip onto the motor itself. Get it on there. And it goes in. Tight fit. And now I at least have a tight enough, or have a coupler on the end that I could possibly put a nose cone on. But I didn't really want to have to put a motor retainer on here. Now, it was so tight, it's probably the same as a friction fit with tape. It probably would have been okay, but I really didn't want that motor to fall out, so I put in this clip ring, and I'm not sure how well the slots will show up on the camera, but basically this goes on and twists in place, and now you can't actually pull it out because the ring gets in the way. So I also used that for a vent hole for the out bay, but I still then had the risk of it possibly turning after it deployed and then the motor still falling out. And so we designed the av bay around that capability itself, which I laid someplace else. So here's the av bay. It has the featherweight tracker, the mag switch to go with the featherweight tracker. It has a featherweight Blue Jay and a featherweight Blue Raven. The 1-inch Blue Raven goes off of normally some of his bays have all thread that go through. I just screw it down with brass screws. And then these are my attachment points, the ground main, ground apogee connections. I was using the Blue Jay as a redundant apogee here. I don't have those two wired up. I started to prep it for another launch and didn't get it finished at that point in time. There are two tiny batteries that go with the Blue Jay Blue Raven. They would fit in here, and then when it was all done, and then the other battery would slide in there. When it was all done, one mag switch would turn everything on to reverse the polarity, and one mag switch would turn everything off. But so these tabs were then intended to keep that from anti-rotating or rotating and letting loose. And so it takes a little bit to get it started in here, but then it goes down, and these tabs actually go behind that snap ring, and then 4 screws hold it on. Since the shock cords go all the way back to the motor, there's no reason for this to be that strong as far as it's not taking a shock cord hit. And so then I had 2 cords here. The purpose was to do both a apogee, which popped the nose cone off, and then do a main with a cable cutter. So these were intended to be able to go through here. So there's a little bit of cord up in there. I'm going to stick this through here, and we will hook up our nose cone. The nose cone's attached. Easy enough. We're going to do another one here. Now this is the parachute for the cable cutter. It already has a zip tie on it. That zip tie is just to hold it tight while I actually configure the actual cable cutter. So it's a lot easier to get the cable cutter on right when the parachute is already tight and then just cut this one afterwards. So, but again, similar thing. This would go through here, there. They're now have our parachute, and then I would do the cable cutter and tie this back to this piece itself. So it is not feeling the stress of all the nose cone and everything else banging around. It's only on a short string, short line with the cable cutter holding this, so it's not under as much stress or wanting to yank and stuff. So then at the field, the two apogee charges, of which I just have one here, one would go in there, slide in. This may be a mess while I do it in here and try to do it in a little bit quicker fashion. The cable cutter would be here. It also would go in. It is a very tight fit. Everything else would go in. We've got our charges in there now. So the only thing I haven't done here is put in those 4 screws. And then this whole thing, once it goes in, I have a piece of something out there, the wire. Then it goes in, and it's a tight fit, and it eventually relaxes and stays on. So I didn't use any shear pins because done right, it actually stays on tight. There's not much air up here to expand, to pop it off. Deceleration doesn't seem to be a problem, as far as it's not like it drag separates or something else. So I've flown it at least with the K185. I'll do it with the K550 and verify that. But that is in the short straw rocket, all of about 31 inches long, 32 with the nose cone, and a K550 flying inside of it. So that's it. I may actually print some of those in case somebody else wants to try them out. I do have it also sized for the extended closure for the K185. So that's it for the video. Let me know if you have any questions. Thanks. Bye.